Yeah, so good evening to all the students. So I welcome you all to our fourth week interaction of this NPTEL program. So in this week we will be discussing about the concepts you have been taught in this whole week. So I presume the topics are on the auto transformer topics, and yeah, we will see a little bit. Excuse me, someone has joined. Yeah. So the concepts will be basically an auto transformer and the connection of auto transformers and using a two winding transformer as an auto transformer and how the losses will be, how much power is transferred, how much power is conducted, and total kVA handled by the transformer. These kind of concepts have been taught over this week. So I'll be discussing those topics now. So let's discuss initially small concepts on auto transformer connections, how we can connect a two winding transformer into an auto transformer, how we can step up and step down voltages using a two winding transformer, and how we can suitably connect those two winding transformers such that we will get multiple voltages as an output with a fixed transformer ratings. So that we will see, and post that we will solve few numericals related to your assignment questions, which will help you solve those assignment questions for the current week. With that introduction, uh, let's get into our discussion. Before right away going to solve for the problems, let's discuss basic concepts on the auto transformer winding and how windings of auto transformers are connected and such basic concepts. So let's start with a two winding transformer. Let's say you have a two winding transformer and you want to connect that as an auto transformer. So going to that point, let's start with a two winding transformer. So let's say is it visible here? Yeah, I'm drawing it here. This particular auto transformer concept is pretty interesting. So if you try to pay attention, it will be pretty interesting to understand this auto transformer connections. So yeah, let's draw a true winding transformer now. We have two separate coils here. This is primary winding and this is secondary winding, as you can see. And let's also take the dot polarity here. You know, the dot polarity at one dot polarity the current is entering and the other dot polarity the current should leave. That's the transformer principle, dot polarity. So yeah, let's, for the calculation purpose, let's take the rating of this transformer, that is 10 kVA transformer, and 500 by 200 volt single phase. Yeah, so this winding is 500 volts, that is HV winding, and this particular secondary winding is, let's say this is LV winding. Yeah. Now, once we know the ratings of the transformer, we can easily calculate the rated currents at each winding. Now let's calculate rated currents. 500 volts and 200 volts. Now at this winding, what will be the rated current? So it's a 10 kVA transformer. kVA divided by voltage will give you the rated current. So, and how much is this? 20 amps. So on the HV side we have 20 amps. So on the LV side the current will be more. Let's see how much that current is. And this is 50 amps. So yeah, basically on the LV side you will get more current and the HV side will get less current to balance the power balance. So yeah, so this is a two winding transformer. Now we have connected two windings as two winding transformer. There is no connection between them. There is isolation here, and all the transformer principles will work here. Now what I am trying to do, like, one second. Yeah. Now, if we apply a 500 volts to this particular transformer, we will get 200 volts. Now, like that's the prime. Okay. Yeah, that's the primary voltage here. There is a 500 volts, and we are getting 200 volts. Now, let's say you are in a lab. Now, you have this particular transformer, the same exact transformer with this particular ratings, 10 kVA, 500 by 200 volts, single phase transformer you have. Now you have only this supply, 500 volt supply. Now, but you are asked to supply to a load which is of 700 volts. Now you require a load. Now you have to supply 700 volts to the load. That means you are having this particular transformer only, and in the lab itself you don't have 700 volt supply, but you have 500 volts and 200 volts transformer. Now, can you do that? Can using this transformer, can you supply the 700 volts load? The answer is yes. Yes, we can supply 700 volts. We can supply 700 volts load using this same transformer of the same ratings, given that we suitably connect these windings in such a fashion so that we can get 700 volts as an output. That we will see how we can get 700 volts from this exact same transformer. This is a two winding transformer. Now let's see what kind of connections we can do so that we can get 700 volts. So let me draw. So now I'm connecting these two windings in series fashion. Let's say this is my HV winding. I will write 500 volts, 50 hertz, and I'm trying to connect in series. This is my 200 volts. Yeah. Now, so there is this 500 volts coil. Now, and let me also give this dots here. This is dot for 500, and there is this dot for 200. Yeah. Now you know, if this is the transformer, the moment you apply 500 volts to the primary winding, you will get the 200 volts. That's the transformer principle. Why? Because once you give the 500 volts, the flux will set up, and based on the turns ratio in the secondary also, the flux will set up, and 200 volts is obtained at the output. Now, what I'm trying to do is, I have given 500 volts at the supply. So now, yeah, here I'm going to give the 500 volt supply, and with this I also know the polarity, and this is if this is I'm trying to supply, and I will get 200 volts here as well. Now, can someone tell me, if I connect these two windings in this fashion, I have connected in series fashion, I am seeing how much voltage I'm getting at this end. It's simple. Now I have connected 500 volts and 200 volts in series fashion. Now I must get 700 volts as an output. There is no load. I didn't connect any load yet, but I will get 700 volts. It's simple series connection. But the thing is, we achieved this kind of 700 volts using our own transformer only. There is still the ratings are same, 500 volts. I'm getting 200 volts. Still, I'm able to get 700 volts just because I did this kind of connection, suitably connected, so that I will get a 700 volts output. So this is interesting because now it's nothing but a auto transformer connection. Auto transformer. Why I said that auto transformer? Because the input is the input is 500 volts. The output is 700. It's like I'm stepping up the voltage. Input, I'm stepping up my 500 volts to 700 volts. That's auto transformer. What does it do? It step down and step up the voltages. So this is like this nothing but a auto transformer stepping up operation. Now, what we have to see here is, the interesting thing which we have to see here is how much current will that input and output will be allowed. Now, let's say I have connected this kind of connections are there. Now, when I'm given a 500 volts, some current will be drawn from the supply, and when I've connected these two windings in series, some current will go through the load. Now, let's say I have connected. Sorry, what is this? I have connected a load here. Load, and whenever I connected a load, current will flow. Now I want to know how much current this particular this load is happening. So we see the rated current at 200 volts coil is how much? We have calculated here. So for this 200 volts, the rated current is 50 amps. So we have we definitely know when there is a secondary coil of 200 volts, when the rated voltage is appearing, how much current should go? 50 amps. Now we already know through the load 50 amps is the maximum current. So until and unless the current flowing through the 200 volts is 50 amps, I don't have any problem. So I'm not overloading the winding. So what is the rated current? I am flowing that 50 amps is current. Now that's fine. Now there is no problem. So from this particular dot, when I say from the secondary of 200 volts, 50 amps is leaving, like this particular. If there is a 50 amps, or let's say there is a load here, 50 amps. Now I know how much current will the primary will draw. How much? That is nothing but 20 amps, because it must draw. So it must, through this primary winding, 20 amps must flow. So that is this winding. It 20 amps must flow. So here it already took 50 amps, and I know if a rated voltage and rated current flows through secondary, how much current the primary should draw such that the rated will happen. That is nothing but 20 amps. Now if we see, since my primary is drawing 50 and secondary is drawing 20, now we know how much the total current would be. So apply KCL here. 50 amps is leaving here, 20 amps is leaving here. So how much current should enter at this point? It is nothing but 70 amps. So yeah, it just satisfies the KCL. Now my input current is 70. Here 50 is flowing. Through the load 50 amps will flow, and here again 50 amps will return. Here again this 20 will join here. Here again KCL 50 plus 20, and 70 is returned back to the supply. So if you see here, now I have used my two winding transformer as an auto transformer by connecting in such a fashion, and all my ratings are satisfied. Now my all the two windings are having rated voltage, and my two windings are carrying rated currents. I'm not overloading the windings. Still I'm able to get 700 volts of the output. So this is some kind of interesting phenomenon which we can make use of using our two winding transformer by connecting in such a fashion. Now let's see. Another interesting thing is we have seen the currents that windings are handled. Another interesting thing is kVA. We know our transformer originally is 10 kVA rating. Now if we see this circuit, let's see how much kVA is being handled by this entire auto transformer. Now let's see. What is my counter? Yeah. Now yeah. How much kVA a transformer is handling? Yeah. So when we talk about handling kVA handled by a transformer, we should see how much kVA is supplied by the transformer, how much kVA is delivered to the load. So this is nothing but the total kVA handled. That is equals to the total kVA handled by the transformer. Now let's see. Let's calculate. From the load side, output side, if we see, we call kVA supplied to the load. How much is output kVA is equals to 700 volts. You can see here the voltage is 700 multiplied by 50 amps. How much it is? 35 kVA. So this is the kVA that is supplied to the load. So if there are no losses, the same kVA must be supplied by the source also. That is the source supply. Let's see that as well. For the input side, now we call this as kVA drawn from the supply. How much is it? kVA input. How much is volt? 500. Because this is input now. This is the input, and this is the current into 70 amps. Okay, so Since this auto transformer is ideal, we can see the output kVA and input kVA are matching 35 kVA. So that's how it should be, right? Whatever kVA I am supplying from the load, the same kVA should be delivered to the load. So now, 1 second, someone has joined. Yeah, here is the interesting part. If you see, let's say I have not connected my transformer in such a fashion. Let's say my transformer is like this only, my original transformer, this particular. Sorry. Yeah, let's say my transformer is in this particular connection. Can someone tell me how much kVA is handled here? It is nothing but the rated kVA. If you see in the primary 500 volts and it is 20 amps, 10 kVA, and in the secondary side it's 200 volts into 50 amps. That is again 10 kVA. If I use my transformer as it is as a two winding transformer, I can able to handle only 10 kVA. But when I connect my transformer as in this fashion, that is this auto transformer fashion, I am able to handle 35 kVA altogether. So this is some real improvement in the kVA handled. But one should get a doubt that from where this additional kVA is coming. Because I haven't changed anything. I just connected these two in series and I have given my rated voltages supplies and I saw the output voltage. From where this additional kVA? So let's see. So 35 kVA minus 10 kVA. So 25 kVA I'm having extra. I'm getting it from where I'm getting this 25 kVA. Can
Sir,
anyone?
due to number of tons increase.
I haven't increased the number of turns. The same number of turns are there now. 500. The primary winding turns are as it is. Secondary side turns are as it is. MMF balance is there. N1, I1, N2, I2, everything is balanced. I haven't changed the number of turns. Just think the difference between the our original transformer, this one. Sorry. Just looking at
Sir,
the.
due to flux change.
Sorry. Yes, Tanuj, can you
Sir,
repeat?
due to flux change.
No, I mean there is no flux change. Like flux induced whenever I gave 500 volts to a rated voltage to my primary, the flux is induced and the same flux is balanced in the secondary as well. The same flux balance is there. Still flux balance is there. But what extra you can see here in this right side transformer and the left side transformer? What additional thing you see here?
Sir, secondary voltage.
Output voltage.
Output voltage is nothing but the series voltage. Yeah, that's we have more output voltage. But why we got that more output voltage? What made my output voltage increase?
Then number of turns increase.
Number of turns. Yeah, see, number of turns are same.
Addition of the turns, sir.
Yeah, addition. Like we have electrically connected these two windings. My number of turns are same. Let's say my primary windings and secondary windings are there. Previously, the only difference is previously it is isolated. There is no electrical contact between these two windings. My flux is induced by this transformer induction. But now I tried to connect these two like in this fashion where I have introduced an additional electric connection. So if you see here, this particular part is my additional electric connection I have been. These are electrically connected now. There is no isolation anymore between primary and secondary. So this particular electric connection is the reason for this additional kVA being handled by the transformer. Now let's look into it more. Yeah. So I'm just writing it here. Now I'm writing an important point. 1 second. Someone has joined. Okay. Now the very important thing we have to notice is In auto transformer, the power is delivered from primary to secondary in two ways. That's important. That's very important. We are delivering my power from primary to secondary in two different ways. So anyone can tell me those two? What are those two? First one is nothing. Is easy. That is through my transformer action. This transformer action power delivery is same in my secondary two winding transformer as well. Why this is due to transformer principle. When you give a rated voltage in the primary, the flux will induce. The flux will cause that will cause EMF induced in the secondary coil due to the change in flux, and my secondary voltage will be induced. So this principle is same. This is my transformer action. So this is one way, but the second way will be
Electrical connection.
that's right, Pawan. Through electrical, you can say it's not indirect. It's through direct electrical connection. So this is an important point to note because usually this kind of phenomenon we don't see in a two winding transformer, which is isolated, where we are providing isolation. But when we connect these two in a series manner, we are introducing an electrical connection. So that must be the cause for the additional kVA being handled. Now you can connect this winding in any fashion. Now it's just now we saw what we saw just now. This is a 500 volts I'm giving. You're getting 700 volts. It's nothing but a step up operation. Even if you do step down or step out or you interchange any windings, this phenomenon will stay same. My power will be transferred by both transformer action and the electrical connection. So yeah, that's an important point. Now let's say no, yeah, the answer for the question is the additional 25 kVA is being handled by this electrical connection. So that's how I'm getting more kVA handled even after my transformer is only 10 kVA rated. Yeah. Now let's see. Sorry. Let's try a different kind of connection now. Just to see what other connections we can make. Okay. Let's take my, let's say this is 200 volts, same transformer. This is 500 volts. Yeah. Now let's say in my lab I have 700 volt supply. Okay. Now I want to feed to a 200 volt load. What transformer I have? I have 500 and 200. Now I don't need to supply for a 700 load. Instead I have a 700 supply. I want to feed to a 200 load. Now for that purpose I am doing this connection. These two I will connect, and this one. Yeah, so I will mark the dots as well. Yeah, now I'm taking output at this particular point. Now I'm giving a supply. Why not? I can connect like this because I have 500 volts and 200 volts winding which can give me that voltage. I will connect those two in series and I will give 700 volts supply from my lab. That's possible. Now in the output I will get 200 volts. This is plus and this is minus. So yeah, I will just draw. Let's say it is my. I'm just drawing the two winding transformer of how it looks like. Yeah. Now it is a step down connection. Yeah, because it is clear because we are giving a 700 volts and the output we are getting only 200 volts. Now I'm going to ask you a question. Same thing which we did before. How much current is being handled here? Now I want everyone to take your pen and paper and give me each and every current flowing through. Let's say now I want everyone to solve I1, I2, I3. So yeah, if this is I1, of course this is I1. Let's say I have connected a load. Now, yeah. Now please give me this I1, I2 and I3 values. And I need directions also. Just now we saw the case for the step up operation, right? Now please solve for this I1. It is simple KCL, KVL, and also ratings. Now you remember the 500 volts. I will write for your purpose. Now how much current my 500 volts will handle? 50 amps, right? That's the current I can handle. Yeah. Now let's say the current that should flow through the 500 volts winding is 20 amps, and the current that should flow through 200 volts winding is 50 amps. Now with this information and this rating information, please tell me the values of I1, I2, and I3. I need directions also. Just think for 5 minutes and tell me what should be the values of currents. So which first current you will solve for? Which is very easy to solve? Which current you will get easily? It should not. You should not take that much time. It should be easy. Which current you will try to solve first? Okay. Tell me how much should be I1, the current drawn from the supply. If you're confused, just see where that I1 current is going. I1 current is directly going to 500 volts. That means my 500 volts winding is drawing that current. Now can someone tell me how much that current I1 should be?
20 ampere.
That's right, Pawan. It should be 20 ampere. Correct. Because under any circumstances, whatever may be my supply, whatever may be the output, my 500 volts winding can draw only 20 amps because that's the rated current. I don't want to overload my transformer winding. So I know I1 is equals to 20 amps. That's fixed. I fixed. I1 is equals to 20 amps. The direction is I already marked the direction. That's okay. Now there are two ways to get the rest of the currents. I will solve one way. Let's say previous question what we did KVA balance, right? Input KVA is balanced by the output KVA. Now what is KVA input here? Just now Pawan said that it's 20 amps. That is correct. Now input KVA is 700 into 20. How much it is? 14 kVA, right? Now the same KVA must be delivered to the load because KVA balance will always be there by transformer. How much KVA it is handled, it should be balanced. Now my KVA output is also 14 kVA is equals to, I know output voltage because I already know I need to get 200 volts. Now I need current. How much current it will be? I is equals to 14 kVA divided by 200. Now what is my output current? 14 kVA divided by 200. How much? It's 70 amps. Now I3 is equals to 70 amps. You understood how we got the 70 amps? We just use simple KVA balance. That's it. We know the input KVA. We know the output KVA must be balanced. So we got the 70 amps current. Now if you see, now it's just simple KCL. At this point, I am having 20 amps. At this point, 70 amps is leaving. And what is the current I2 here?
50 ampere.
Yeah, 50 amperes leaving or entering that node. This is the node. It should leave or enter that. At this, if this is the node, my 50 amp should enter.
Entering the node.
Yeah. Yes, Tanuj. So you see, KCL and KVL are universal laws. They should be satisfied anytime, anywhere. So if you see now, 20 amps is entering here, 70 amps is leaving. So from here, my 50 amps should enter. Now, if you again see the balance, cross check it. My 200 watts, my 200 volts winding is should only able to deliver 50 amps. Only 50 amps should pass through that winding, and it is satisfying there. Now, if you again check I1, is I1 that is 20 amps is returning. Now, if you see my load, 70 amps is flowing, and 70 amps will come here. At this node, my 50 amps will go towards will leave that node, and the rest 20 amps goes back to the source. Now again, my I1 is satisfied. Yeah. So now, if you see this kind of connection, we made a step down connection. We connected two coils electrically. Still, all the ratings are satisfied. My 500 volts is having 20 amps. My 200 volts is having 50 amps, and my input and output kV are balanced. So yeah, this is what advantage of auto transformer is. Keeping all my ratings in condition without overloading my transformer windings, I can get different combinations of output voltage, input voltage, and different kVAs I can handle. Now, in the first case, how much kVA we handled? It's total 35 kVA we have handled. Now, in this case, we are handling 14 kVA. Of course, it's not that much kVA, but it's still more than our rated kVA. My rated kVA is 10 kVA only. Still, I am able to handle 14 kVA here. So now you can tell from where my 4 kVA extra is coming up. That is nothing but through the electrical connection. See, yeah. Yeah. So I want after this session or before next week, I want you all to try different connections here. Now I just took a 500 by 200 volt transformer of 10 kVA and I connected step up and step down. I have showed you how step up connection can be done, and then the step down connection is done. I want you to do it for different combinations, step up and step down, and you interchange the dot polarities, you interchange the windings, and try different connections and just play with it and work on this KCL KVL ratings. So it will be fun, and you will actually enjoy doing this kind of problems. So yeah. Yeah, I forgot to tell you. So there is another way of finding these currents as well. I told you there are two ways. One way is through KVA balance I did, and there's another simple one. I will just show it here. So this is the connection, right? So here I have given 700 volts, and this is my 500 volts. Now I know there is a 20 amps flowing. Here I am taking the output, right? So this is 20 amps. I know that, and drawn by the supply. And once I give rated current and rated voltage to my primary, I know how much my secondary will draw, right? So see here, this see here everyone. So here I have given 20 amps. Now as soon as I give my rated voltage to my primary and I flow 20 amps rated, my secondary will be experiencing 50 amps current leaving the dot. Now this is the dot, and I can clearly say it is 50 amps. Now again apply KCL, 20 here, 50 here. So 50 plus 20, 70 will leave here. So this is again 200 volts, this is 500 volts, this is 700 volts. This simple way, through the transformer principle we said that. So either KVA side you can do KVA balance, or through the transformer principle. Both ways you can just tell how much current my primary and secondary can able to handle. Yeah, so that's all about auto transformer connections and how we can use a simple isolated transformer, two winding transformer as an auto transformer for different connections and different polarities to get different step down and step up voltages. So I hope you have understood this concept. So with this concept, we will move forward and we will solve a couple of questions, and then we will close the session. So yeah, everybody please take pen and paper with yourself, and these are very simple problems if you understand the concept what we discussed. So yeah, so please try to draw the figure first. If you draw the figure whatever from the data we have provided, 80% problem will be solved. It's just a simple calculation will be left. So seeing the question, whatever data is given, you just try to put that data in form of a picture. So I want everyone to solve with me. So yeah. 10 kVA, 2200. It will help you in solving your assignment problems as well. So please try to solve with me. It's yeah, two winding transformer. Okay, we have given us some efficiency values and power factors. We will just note them. Full load efficiency is 94%, and at what power factor? It's 0.75 power factor. Okay, this is an additional information which was given. Now, this is the important thing. Now, the transformer is used as an 2200 by 2300 auto transformer. Now, see, we are having 2200 by 110 volts. Now, we are using this as a 2200 by 2310 volt transformer. 1 second. Yeah. Now, if you see, my supply to the two winding transformer is 2200. The auto transformer supply is 2200. Same supply. So the my primary winding, which is HV side coil, is same. Now my secondary is 110 volts in my two winding transformer, but here it is 2310. It is nothing but addition of 110 and 2200. So I will give supply to my HV, but I will take output for both HV and LV. So that's it. So we will draw that. Now let me draw. This is my HV, 2200 volts, and yeah, this is 110 volts. Now I have connected these two, and this is my dot. This is my dot. I am taking supply output voltage here. Now if I am giving supply here, I know the polarity and I know how much is induced, and now I am taking 2310 volts. See, yeah, now this is I1. Now this is, let's say I have connected a load. This is I2, and the same current will come back I1, and there is I3. Yeah. Now we have put whatever we have given the information in terms of picture. That's fine. Okay. Now let's see what was the question. The question is we have to estimate the power output of the auto transformer at full load and unity power factor. So I am operating my transformer at full load. Now we just need to calculate the output power. So this output power, how much power is delivered to the load. Now my power output is equals to output voltage multiplied by output current. It is I2 here, right? I have to calculate this output power. Now, can someone tell me how much is I2? How much is I2? Because if I get I2, I can calculate. It's nothing but the current through the LV winding. I know the ratings of transformer, that is 10 kVA and LV is 110.
Sir, 70.
Sir, 90.9.
Okay, yeah, 90.9. We will come to that. That's correct. So someone said 70. Can you tell me how you got the 70? There might be some confusion for you because
The calculation is good.
okay, fine, no problem. Yeah, someone said correct answer 90 amps. That's absolutely correct. Yeah, so because we know the kVA rating of my transformer, and you see the LV winding, the current is flowing through the load through my LV winding. So for that, I cannot overload my LV winding, so that I will calculate whatever the rated current my LV winding can handle. That's my output current. So kVA divided by 110. So 10 by 90, we should get some 90.90. How much is it? Let me get my calculator. Get 10 into 10 cube divided by 110. 90.9090 amps. Yeah, 90.90 will do. Yeah, so this is my LV. So let's calculate HV as well. Just it would be useful. 10 into 10 cube divided by 2200. I'm calculating I3. So okay, someone tell me how much it is. Yes, correct, Tulsi. It's 4.5454 recurring amperes. Yeah. So you can see high voltage current will always be less than LV current. That's also tallying here. Yeah. So coming back to our question, we need to calculate the power output of the transformer. So now simple. The power output is equals to V output 2310 multiplied by I2. How much is I2? I2 is nothing but ILV. I2 90.90. So how much it is? How much you are getting? 2 it's 209 209.97 kilowatt. So everyone's getting the same. It's around 210 kilowatts. Okay. I hope it's simple only. We just visualize the diagram and we can calculate it. Now let's see the second question. Estimate the power transformed by the auto transformer at full load and unity power factor. Now it's how much power is transformed by the auto transformer. When we talk about power transformed, it how much power I'm giving to the transformer to transform. Let's say some power is being delivered to the load, but how much power I'm transformed by the auto transformer. That is, if you see this LV winding, I'm giving a supply V1 and I1, some current and some voltage. My auto transformer is transforming that power to the secondary. So if you see that, can someone tell me how much is I1? Input. This is I1 and this is I3. That is
95.44, sir, I1 ampere.
I1. I1. You are saying this input current.
Yes, sir, input current.
Okay. Yeah. See, correct, because I3 will flow through here and I1 is coming back and the same number of I2 is come. So yeah, 90 plus 90.9 plus 4.54. That's absolutely correct. But sorry, someone has joined. Let me. Yeah. Now, yeah, we calculated the power output. Yeah, you're correct. Though whatever current we are supplying, it's been divided into some current is flowing through the load. That is I2. We see how much I2 we got. That is something but our low voltage current. That is my LV winding current can handle only 90.9 ampere. So yeah, that is being flowed through the load. And my primary winding, if you see, that is my HV winding. We can only flow 4.54 rated current through that winding without overloading it. So if you see, that is the power transformed by my auto transformer. So by how much power has been transformed by the primary winding? Let's calculate that. ILV, so yeah, IHV multiplied by my HV. So how much is I3? It is 4.5454 multiplied by 2200. So this should be how much my primary winding of my transformer is being able to transform, like the power my primary winding can transform. So sorry, someone calculate this. 5454 multiplied by 2200. Yeah, 9, 9, 9, 9, 9, 9.88. So it's around, it's in watts. So it's 9.99 kilowatts. So we see we have estimated the power output, that is around 210 kilowatts, and the power transformed is around 10 kilowatts. Now the total power handled by my transformer is 210, and out of that only 10 kilowatts is being transformed by my primary one. So now we have to calculate how much power is being conducted. Now let's get back to our points where we discussed. So you see, in an auto transformer, the power is delivered from primary to secondary in two different ways. That is through my transformer action, that is my power to transform through my transformer actions through the flux. My primary winding I give a rated voltage, and according to that, my LV winding will experience the same flux. Flux balance will be there, and my power will be transformed. And the second thing is through direct electrical connection. Now we saw how much difference we have observed, how much kVA difference we have got by this electrical connection as well. Now to apply that concept in this problem, the first question we solved is the total power output. So we have got around 210 kilowatts of power. But if you see my primary winding can only handle 2200 volts, 2.2 kilovolts, and 4.54 amperes. So what is my power there? It's around only 10 kilowatt. Now, if you are asked to calculate the rest of the power conducted, it must be the total power output of the auto transformer subtracted from we have to subtract my power transformed from the total power connected. Now my total power output is equals to 209.9 kilowatt, and my power transformed is equals to around 9.99 kilowatt. Therefore my power conducted by my auto transformer will be 209.9 minus 9.99 kilowatt. It should be around 199 something, right? 209.99. Yeah, it's exactly what I'm getting is 200 kilowatts. So if you see, I have seen now we have seen the two kinds of actions here, the power conducted and the power transformed total contributes to the total power output. We have already did this kVA balance while we are discussing the concept. Now we have just applied that in a numerical problem as well. Now moving forward,
Sir,
yes,
power conducted means power conducted due to electrical conduction.
right, yes, you are correct. So now let's see, we are asked to find estimate the total power loss in the auto transformer as the function of power output at some load and some power factor. We are given with a full load and pointed power factor. Now see, we have to calculate the power loss in the auto transformer. So let's say whenever we talk about losses, we should know how much we are giving as an input, and we should know how much we are getting as an output, and we subtract input from output from the input, we will get the losses. In second, someone has joined. Yeah, so we will get the losses. So when my transformer was operating as a two winding transformer, what will be the losses? So let's say I am operating my auto transformer as a two winding transformer. Now it means there is only isolation, there is no electrical connection. Now yeah, if it's an ideal transformer, I should not there should not be any power loss in the electrical connection when we connect into auto transformer, because we see whenever we connected my isolated transformer into auto transformer through the electric connection, all my currents and voltages are same as in the two winding transformer, right? There are no changes in the voltages and currents. There are no losses in this. Copper losses are not there because same amount of currents are flowing through the windings. Even if I connect as a two winding, even after I connected that as a auto transformer. Now let's say in two winding transformer, how much power is being transformed? That is the power transformed through transformer action, right? Now it's around 9.99, right? Yeah, it's 9.99 kilowatts is being my the whatever power I have transformed this. Now,
Sir, sir, actually, before ending the session, I have a question regarding the assignment one. I
yeah,
have solved that assignment one, but I've employed the formulas regarding the questions, but my answers are not to the point that I was expecting that they were right, but they were not. I've applied the formulas. So what was the thing wrong? I just want to ask those things, sir.
okay. So which week assignment you are talking about?
So week one assignment.
So are you provided with the solutions?
Yes, sir.
Okay,
Yes, sir. I'm provided with the solutions. No, sir. Just the one word answer, accepted answer, sir.
okay. There is only one word answer.
Yes, sir.
Okay,
But the result that I have obtained, I have also asked my professor about the questions. He helped me in solving that assignment, but at the end, finally, the answers were not correct.
okay.
So that was the reason I just want to ask that.
So definitely, what you can do is you just post your query and whatever solution you have made in the discussion forum. So once this session ends, our TS will go through that question and solution you have posted, and you can also mail to our ID. We will check the solution. We will get back to
Sir,
you.
can you, sir,
Yeah.
as just one request,
Yes,
hello,
please. Yes, please, please go on.
sir, I've actually attended one NPTEL session, basic electric circuits. There, the Jendra sir gave us the whole answer solutions of the questions by handmade solving. That how he solved the questions.
Okay,
After that, that copy of solution PDF they have posted on the NPTEL website,
okay.
and we will get to know about that how the question is solved. So, sir, can you just please do the same thing for electrical machines because, sir, it is very important from the electrical branch point of view, sir.
Now,
Yes,
what
sir.
are
So,
the the solutions provided to you? Were they not clear?
sir, actually, only the board work is given, not the correct solution work given.
No, apart from board work, you will have complete set of solutions for each and every assignment question you were asked. There will be separate PDF. We are uploading that.
So, you have uploaded right now.
No, no. In your portal, for every week after that submission has been done, I think you will be having the PDF of solutions also. Whatever questions
Has
you have,
anyone
whatever.
received
Okay.
has anyone received it in the group? Just please let me confirm because I think I didn't receive.
Okay, I will do one thing. After this session, I will go to your new course portal and I will see whether the solutions for the assignments have been uploaded or not. Or else, before next week, I will try to make sure of that. Okay, Tanuj?
Thank you. Thank you so much, sir. Thank you so much, sir. So
Definitely.
nice of you, sir.
Thank you, thank you. No problem. Okay, so let's get back to our discussion. It's already 5. So yeah, let's see quickly. So it's nothing. It's very simple problem. So let's say my 10 kilowatts is being transformed. So I know already how much power I have transformed through transformer action. But I want to know how much has been supplied. So let's say this is my output. Now I want to calculate loss. It's nothing but input minus output. So how we can write input? Input is nothing but output by efficiency minus output. Now how much is my output? 9.99. It is always kilowatt here. How much is my efficiency? It's 94% efficiency minus 9.99 into 10 cube. So this is my losses that has been I have I have experienced this much of loss when I'm trying to transform my power. So I will get some loss. Let me quickly calculate that as well. Um, 1.99 So I'm having around 637.65 watts as my loss. So okay, uh, yeah. Now what can be done? So yeah, now I cannot write it as watts as well because this particular 9.94 efficiency is at 0.75 power factor. Now when we say Vi cos 5, this will be my output. Now I have to multiply with power factor here as well, and I forgot about it. 0.75, 478, right? I don't know how much that value is. Let's see. 478.244. That's my actual power loss I'm experiencing, watts. So I want to stress one point here. Whatever may be my power factor, whatever at what load you are operating, if the operating kVA is same, if you are using the same transformer, in both cases our loss should be same. So your core loss won't change, your copper loss won't change, because the same amount of current is flowing in both cases, right? In two winding transformer, in auto transformer, the currents, the voltages, all are same. So in both cases your losses remain same, even whatever power factor you are operating in, whatever load you are applying operating in, given that in both cases it should operate at same load and same power. Now you see that now the question is, it's not completed because it's as the percentage of power output. Now 478.244 is the loss. Now it's a loss. Now total power output is how much? Sorry. Now what is my total power is 209. See, 209.97. Let me share my screen again. So yeah, 209 is my total power. Now we have to just write my loss in terms of percentage of the total output. So yeah, my output is 209.9 kilowatts. Now my percentage loss is equals to 478.244 divided by 209.9 into 10 cube into 100. So someone do the calculation along with me. Answer 209.99 into 10 cube into 100. It's sorry, it's 0.227 percentage. So it's nothing but an extension to our auto transformer concept. We have calculated the loss. The loss will be only in the transformer power, because you are assuming an ideal transformer and all the currents and voltages are same. You can experience only loss during the transformer action. And we took that power 10 kilowatts as we calculated the loss, input minus output. Input is nothing but output by efficiency. We were provided with the efficiency, and we calculate the loss as a percentage of total output power. So the main important concept you have to keep in mind is, in this auto transformer, how I can connect my two winding transformer as an auto transformer to get different step up and step down operations, and how I can balance my currents in every point of the node of the transformer such that my KCL is balanced and my transformer windings are not overloaded, and I will get good flux balance will be there. So whatever my primary winding is supposed to carry rated current, the same current is flowing or not. That particular point you have to keep in mind while you are connecting different kinds of connections for this auto transformer. So yeah, and this is important point in auto transformer. The power will be delivered in two ways, that is through transformer action and through electrical connection. So that's how we get increased kVA handling by the transformer. And yeah, we have solved the simple problems on it. You just see what my HV winding current, what is LV winding current, and you can calculate any kind of power loss, conducted power loss, transformer power loss, and total power output. So yeah, and with that, uh, I close our discussion today, and I hope you have understood the today's session. Yes,
Sir, I want to some questions.
yeah, please,
सर
Paul.
सर कैन आई आस्क इन हिंदी?
Yeah, sure, sure.
सर मैंने एनपीटीएल का 3 असाइनमेंट नहीं सबमिट किया है सर, तो क्या मैं एग्जाम दे पाऊंगा इसका?
Okay, उस बारे में मुझे भी इतना आइडिया नहीं है, तो आप कोई आपका इंस्ट्रक्टर या कुछ है, कोई आपका सपोर्ट, एनपीटीएल सपोर्ट कोई है?
नहीं सर, वही तो मतलब सही से गाइडेंस नहीं मिल पाया। मैंने एनरोल किया लेकिन उसके बाद फिर डेट मिस हो गया और मैं नहीं कर पाया।
आपका डाउट ये है कि आप असाइनमेंट्स सबमिट नहीं किए थे, 3 असाइनमेंट्स.
यस सर।
So still, are you able to attend the exam or not? That's what your doubt is.
यस सर।
Okay. So yeah, I will try from my end. I will contact my instructors and I will see whether I can. देखता हूँ अगर मुझे कुछ पता चला तो आपको बताऊंगा next session में.
थैंक यू सर।
Okay. Please आप
सर जो इनको
deadlines
इनको
miss
बाकी
मत
के
करना.
9 असाइनमेंट्स वो करने पड़ेंगे ना
Sorry.
अच्छी तरह से। सर इनको बेस्ट ऑफ 9 असाइनमेंट्स करने पड़ेंगे ताकि इनका एवरेज स्कोर 25% बने,
Okay.
तब जाके ये एग्जाम वो दे सकते हैं। और एग्जाम में इनका 75 में से 30 बनने चाहिए मार्क्स, तभी इनका
I understood.
सर्टिफिकेट अलॉट होगा।
So अगर assignment submit नहीं किया तो problem होगा ना?
यस
Okay, fine, but I don't know what's the minimum number of assignments you have to submit, but I don't think you can miss the assignment submission. Please don't encourage this from next time. You try to submit assignments within deadline. Pawan. Okay.